Hello, everyone. Good afternoon. I'm Tatsuo Unemi from Soka University in Tokyo. Today I talk about our collaborative project with the two Swiss guys, Daniel Bisig and Philippe Kocher. Unfortunately, this is the time of the 1 o'clock, so then it might be, what time is it now in Switzerland? But anyway, it's almost very early morning, so I guess they are sleeping. So this is our introduction to our artwork, entitled "Greedy Agents and Interfering Humans." The subtitle is "An Artwork Making Humans Meddle with Life in the Machine." So let's go. Yeah, so the background image is captured in a last exhibition in Weimar in Germany. So I think that some of the you guys might know about some history or some relation among the new media arts using a kind of technology of artificial life or some concept of artificial life. So then maybe many of the artworks are using serial automata or L system, some morphological some development of some of the plants or some animal or evolutionary algorithm to get some unpredictable some shape or sounds or so many things. And of course, another thing is a very useful for from the viewpoint of artist is a kind of collective behavior, typically in Craig Reynolds voice algorithm or ant colony algorithm. And then sometimes some artists that try to make a robot to draw something or make a sound or something. So of course, sometimes such a physical installation combined with some complex controller can produce some spontaneous, some unpredictable something, so complexity something. Of course, not only such autonomous artwork, but also interactive art is also very interesting. So yeah, me also interested in some artwork that can interact with the visitors. So affecting the generative mechanism from visitors. Yeah, of course, it's it must have some feedback circuit the affect from the visitors to artwork itself. So then yeah, this time after the corona pandemic is a little bit not finished, but then we restart the collaborative project, and then we start some idea to build some reinforcement learning agents interact with the visitors. Yeah, of course, this is a little bit different. Yeah, of course, we need to distinguish the two different categories of the creation. So one is that we can use the evolutionary algorithm or something typically in the interactive evolutionary computation to produce some artwork. But in this case, it's the artwork itself embed kind of artificial life. So it's a little bit different style. Okay, so maybe almost all of you already know about the reinforcement learning, so maybe I can skip it. Okay. But I want to emphasize the origin of idea of reinforcement learning in the 19th century. So it's the initiator, Thorndike. Yeah, he proposed a basic mechanism framework of human learning using a kind of classic conditioning, but he didn't conduct any experiments. So then you may know that the famous experiment by Skinner. So it's he organized some cage with rat in the cage, and then give him some reward or punishment, and then they change the behavior in the cage. So it's a very clear. And then, so that always some agents is has some information flow, something like that, like this. They catch some information from environments through the sensors, and then they act to affect something on the environment. And inside of the learner, they memorize something, and then always selected his action in a kind of adaptive way. So of course, the evaluation is of course, it's very important embedded in learner. And of course, the some classic frameworks are invented in the 1980s and 1990s. Unfortunately, we are using still some grid world. Sorry, it's a previous presenter is also using a grid world. Yeah, hopefully we want to expand this artworks in a continuous space. It might be more smooth movement or more attractive for the visitors. But anyway, our objective is not to improve any learning algorithm, just using a simple learning algorithm to express our concept. So don't blame me why we are using so simple, stupid, classic words. So then it's a little bit strange, that we are now almost all of the projectors or the display is has some aspect ratio of 16:9. So then we are using the grid world of the 11:6. It's not exactly same, but approximately similar. So then we are using this one. So this selection from the commercial product, the artwork is always affected. Anyway, so then agents we want to travel from the start point to goal position, and of course he doesn't know anything. What kind of the action he took, then what's the environmental change? Is that he has no idea. So then, yeah, he's moving from the start points to goal, and then when he reaches the goal position, and then he received a reward, and then forced back to the start position, and then explore again. So then the learning mechanism is something like this. So it's a very simple Q learning mechanism. So this is the learning rule, and the next one is action selection rule. It's a probabilistic way. And then, yeah, this algorithm is very slow. So then we employ the, it's also class one, linear queue architecture invented by Richard Sutton. So it's a little bit accelerated the propagation of the reward. So then, yeah, also we implemented some interaction with visitors. So this is the setup, some illustration of the setup. Here is the table, and then this is the projector, and then on the ceiling, we equip the connector Azure, I think. So then camera can detect the where the visitor's hands are located. So then, yes. So then when the visitor places their hands at while, and then they are growing some obstacle. So then the agent cannot get into the cell position of obstacle position. So then it might be help agents to prevent the some useless action, or visitor also can disturb their learning process. So it's a kind of the interaction between the teacher and the pupil, something like that. And then of course this is I said this was a bad idea to Daniel and Philip, but it also visitors can affect the memory of the learner itself. So that's a kind of brainwashing. That's is a bad idea. But anyway, it's a fun for the visitor. So this is a setup. So here is a very nice ultra short focus projector. It's very useful. And then yeah, we cannot see any connectors, but anyway, somewhere here. He's a Philip and he's a Daniel. So this is the messy wiring under the table. So yes, 3 persons collaboration among the 3 persons. So each guy operates each small computers, two Mac Minis and the small Windows machines here, and then connected by network. And then we are using OSC protocol to communicate with each other. So then one computer, my role is to build some learning algorithm and the visualization. And then Daniel builds the some image processing part. And then Philip makes some sound generation part. So then I will explain some how to visualize the movement and the memory of the learner. So the background of the slides is some still image of the visualization. So yeah, so we are using a tabular Q-learning. So it's not a neural network. So each of the place cell has 4 vectors that express how much is promising to reach goal. So then this is this kind of the vector can organize the kind of vector field using some interpolation between the nearest vector. So then we, sorry, let me show you my, video. Oh, wait a moment. Yes. Okay. Oh, sorry. Again. So hand movement is slow. When it's slow, then yeah. So this is the obstacle is grown up on the table. So then the white circle is agent. Then he couldn't enter into the cell. Yeah. So then now he intended to how to say confuse him. So then color of yeah. So this particle is a particle flow is following the vector field. So then you can see the different color that's mapped to the speed of particle. So thanks to the recent improvement of GPU, we can operate the almost 1 million particles, but in this case we are using 320,000 particle. It's very fast. Fortunately, might be I made a mistake to set up some sound output here. So I'm not sure whether the remote guys can hear something. Okay, so let's close it. Maybe. Yeah, so the sonification is also very important effect for the as artwork. So the providing sounds for each visitor through the headphone, and then generating the sounds of the neighboring area his or her hands are placed. So mixing the sounds generated using the data of particle flow and the agent movement. So sometimes the visitors are just enjoying the hearing, controlling the sounds. They sometimes ignore what the learning agent is doing. So that's a little bit a different manner of we are expecting for the visitors enjoying. So, but anyway, so our artwork is intended to provide some occasion for the visitors to interact with the kind of I don't know, so agent in the machine or something. So then it's we were conducting another project in almost 20 years ago with some conducting the multi-agent to play music, but it's quite different. Yeah, because in this case, agent can learn, so it's adaptive. But previous case, it's a fixed rule they are following. So, but anyway, it's a collective behavior, so complex phenomena happened. So we really want to expand our work for the direction of multi-agent learning with the continuous space. So maybe it can express something about the social learning and mutual learning, or yeah, sometimes, you know, teacher is an obstacle for learner sometimes. So that's kind of phenomena, so yeah, very often happen. So yeah, of course, there's some of the evolutionary adaptation might be very useful and interesting, but one of the problem is that it needs much of the time. So one of the theory of art exhibition is that usually visitors stop at the front of the artwork in just 15 seconds or something. So that's a little bit difficult to, yeah, something like this. But might be a kind of virtual world meta, something might be useful to realize such artwork, but I'm not sure. Okay, so grid world should be expanded to the continuous, coordinate, and multi-agent learning. We are now planning to expand that one. Okay, so unfortunately, we don't have any exhibition here. But please visit our webpage, and then you can see some video or something like that. Thank you.